Assalamualaikum and hi. My name is Nurul Hanan and I'm from Group F. Our group will be presenting about the MOV group instruction set. And for my part, I will be explaining on the MOV instruction set. Okay, what we have known through our previous lectures in class, we have learned about the register sets, memory map, and the addressing range. What you don't know is the move group instruction set. So we're gonna get over the list of move instruction syntax, the move instruction operation, and the restriction of move instruction. Okay, this is the syntax available to use for the MOV instruction set. The S in the curly bracket here is the optional suffix that can be included or not. That's why there's the curly bracket over there. And if the S is specified, okay, the condition flag will be updated according to the result, which is the N and the Z flag. For MOV instruction set, this action does not affect the C and the V flag. Okay, this is RD, which is a destination register, and RM is a register. The restriction for this instruction is both RD and RM must only be specified from R0 until R7, which is the low registers. And the move instruction can also, the MOV instruction can also move the immediate values into the register destination. But for this coding line, we must include the S suffix to update the condition flag. This is the restriction for using if we want to move the immediate data into the register destination. And for the immediate value, it is any value in the range of 0 until 255. And it can also be written in hexa values. Okay, as shown through these examples, we can see that the values inside the coding for line 1, the values inside R1 will be moved into the register destination, which is R3, and the flag will not be updated because we didn't use the S suffix. Okay, for the second line, it's we're gonna move the immediate data, which is the decimal value of 20, into the R0, the register destination, and the flag will be updated. Same goes for the third line. The hexa values of immediate data will be moved into R1 register, and the flag will also be updated. Okay. Okay, now for the use of program counter, which is register 15, and the stack pointer, which is register 13, R13, in MOV instruction, if we want to use PC and SP, we cannot include suffix S in the MOV instruction set because it will generate error. This is the restriction if we want to use the PC and the SP. Okay, we cannot use program counter for the register destination or any operand in any data processing instruction that has a register control shift. Okay. But except for we can use the PC when, which is for this example, PC will be moved into the registered destination when the registered destination is not PC or stack pointer, which is not PC or stack pointer. Okay, meanwhile for SP or stack pointer, we can use it for the register destination, and also we can use it at RM, which is the register, except for when we use the SP as the RD, the RM cannot be PC or SP. When RM is PC or SP, it's gonna generate error. So this is the restriction for using SP. If we use SP as RM, the RD cannot be PC or SP. So that's all for my part. And the next subtopic will be the move not instruction. Thank you.
Hello, Assalamualaikum. My name is Nur Safian binti Satar. My ID is EA18027. I am second presenter and I would like to introduce about second instruction MVN. I will present about definition, syntax, operation, condition flags, 16-bit instruction, architectures and restriction. Definition of MVN is move not. The syntax is MVN, curly bracket S, curly bracket condition, RD, operand. S is an optional suffix. If S is specified, the condition flags are updated on the result of the operation. Condition, an optional condition code. RD, the destination register. Operand is a flexible second operand. Operation, the MVN instruction takes the value of RM, perform a bitwise logical negate operation on the value, and place the result into RD. Use of PC and SP in 32-bit thumb MVN. Use of PC and SP in 16-bit thumb instruction. Use of PC and SP in ARM MVN. Condition flags. Update the NZ flags according to the result. Can update the C flag during the calculation of operand 2. Does not affect the V flag. And 16-bit instruction MVN as RD, RM, MVN, curly bracket condition, RD, RM. 16-bit instruction, the following forms of this instruction are available in thumb code. And 16-bit instruction, MVNS RD, RM. RD and RM must both be LO register. This form can only be used outside an IT block. Then MVN curly bracket condition RD, RM. RD and RM must both be low register. This form can only be used inside an IT block. For the second last is restriction. We have two restriction. First, in this instruction, RD and RM must only specify R0 until R7. Second, when RD is the PC in a MOV instruction, we should have two restriction. Bit 0 of the result is discard. A branch of occurs to the address created by forcing bit 0 of the result to 0. The T bits remain unmodified. Last but not least, architectures. The correct example is MVNS R2, R0, which is at the previous slide. We can see how to write the correct instruction. MVNS is correct and R2 is RD and R0 is RM. Write inverse of R0 to the R2 and update flags. The incorrect example: MVN PC, R3 AS, ASR R0. Then the PC not permitted with register Control Shift.
Good day to my lecturer, Dr. Badaruddin Mohammed. My name is Devruban Salam Najisegaran. I am from University Malaysia Pahang. I am currently pursuing a second year in Bachelor of Electrical and Electronics Engineering. So hereby, I'm going to present about one of the instruction in ARM Cortex, which is MSR, move to, also known as move to status register. So here we go. So about the description of the MSR instruction moves value or the value contained in source to the CPSR or SPSR. CPSR means that current program status register. It's a core register access. The CPSR holds processor status and control information. On the other side, SPSR meaning that it's a saved program status register. The saved program status register stores the current value of the CPSR when an exception is taken so that the CPSR can be restored after handling of any exception. So the MSR instruction may be used to update the processor mode, code flags, condition code flags or interrupt enables. To select the CPSR bit 22 needs to be set to 0. To select the SPSR bit 22 needs to be set to 1. So then the condition needs to be a valid value, or else the instruction is rendered a no. So that means it's not valid. So the type of syntax from the MSR. So first of all is MSR condition CPSR bit hashtag value. Second one is MSR condition CPSR bit source. The third one MSR condition SPSR bit hashtag value. And the last one is MSR condition SPSR bit source. So these are the syntax for the MSR. So about the condition for the MSR, 1 of 16 condition refer to condition code status. And for the bit, you can see a valid mask bits. First of all is control field mask bit of 16. It's known as C. And then we have X extension field mask bit of 17. And S status field mask bit 18. You also have F flex field mask bit 19. About the value, it has 8-bit immediate value. You can see the addressing mode and the data processing operands from the K. Source is for the source register. The flags affected, as you can see here, N down there we have TM set flag for TM, C flag for TM, B also for TM, and we have Q, S, I, F, and T. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad Nur Sulaiman bin Zulkifli, EA17046. So now I will present about the MSR, move to status register. I will present detail about the MSR. Okay, firstly, we must know what is the syntax of MSR before we write the program about the MSR. So we must see the first one is the condition, which is the syntax. MSR have a condition which is 16 condition refer to the condition code status, and then bit which is a valid mask bit have 4 character which is the C is the control field mask bit, X is the extension field mask bit, S is status field mask bit, and F is a flag field mask bit. And then we move to the value of the MSR, which is 8-bit immediate value, which is the C addressing mode 1, which is data processing operands. And then the source is the source register. Now so we can see the symbol, or when we want to write the MSR. So we must know about this first. Okay, next we move to this one, the third slide, which is addressing mode and the flag affected. So this is addressing mode, which is C addressing mode 1, which is data processing operand, which must generate immediately. And this is the flag affected, which is have many number, but the number NZCV have the value. Okay, next we move to the encoding immediate operand. So this is encoding immediate operand. So you can see this, and you must understand it before write the program. And next, and this is the encoding register operand. It's same with the previous slide, which is the encoding immediate operand, but this is the encoding register operand. I think the difference of this encoding, which is the value SBZ and SBO and bit mask. Okay, lastly is the example of the MSR, which is how to write the program of the MSR. So you can see this at this slide, which is the step how to write the MSR. So when you understand the previous slide, so you will easy to write this program. So that's all. Thank you.
Assalamualaikum. My name is Siti Naraini binti Cik Wahimi, EA18120. Today I would like to present about the instruction MRS, which is PSR to General Purpose Register. MRS is move the contents of a special register to a general purpose register. The syntax of MRS is MRS RD spec register, or can be MRS condition RD PSR. The RD is the general purpose destination register. Spec register is one of the special purpose register like APSR, IPSR, PSR, MSP, PSP, or control. PSR is one of a PSR on any processor in any mode. CPSR is deprecated synonym for ASPR and used in debug state except ARM version 7N and ARM version CM. SPSR is on any processor in privileged software execution only. The function of MRS is MRS store the contents of a special purpose register to a general purpose register. The MRS instruction can be combined with the MSR instruction to produce read modify write sequence. They are suitable for modifying a specified flag in the PSR. In process web code, the programmer's model state of the processor being swapped out must be saved, including relevant PSR content. Similarly, the state of the process being swapped in must also be restored. This operation makes use of MRS store and load MSR instruction sequence. The register restriction for MRA is cannot use PC for RD in instruction, cannot use PC or SP for update in thumb instruction, but can use SP for update in ARM instruction, but this is deprecated in ARM version 62 and above. The condition flag in this instruction does not change the flag. The architecture of MRS instruction is available in all versions of the ARM architecture. This 32-bit instruction is available in ARM version 62 and above, and there is no 16-bit version of this instruction in thumb. For advanced mode is no operands. This is an example of MRS coding. You can see at this coding, they use instruction move and MRS. For MRS, they use CPSR and SPSR. Thank you.